So welcome everyone. My name is Endre, and today I'm gonna share with you my latest work, which was really Kotlin related. It's a CRM case study, and as the subtitle says, how I implemented a query transformer. But before we go into the details, I just want to have some questions. So hands up if you know what is a sealed class in Kotlin and you actually use it. Okay, there's not gonna be so much interesting stuff for you guys. How many of you applied Django 4 design patterns in their production code? Equally? And have you ever dealt with a model transformation in your life? Awesome, okay. Little bit less. Yeah, so I work for Streak. This is a Silicon Valley company. Their main flagship product is the Streak, which is a CRM in your Gmail account. So our target is these small and middle-sized companies, mostly like sales or headhunters or real estate who are dealing with lots of communication. But I will talk about the product in details. Last time I checked, I saw like more than 700,000 downloads just for Chrome, but we also support Safari and Edge as browser plugins, and we also have a mobile application for Android and iPhone. So yeah, it's a pretty cool company though. So this is a screenshot about the product. It's a simple Gmail account. But as you can see, it's slightly differently look like. So this is a pipeline, which is listed out in this left side. A pipeline is essentially a flow where it can describe a product or your own business process. These header banners are called stages. And these rows in this spreadsheet are called boxes. So whenever you have a deal that you want to make or a person you want to hire, you create a box in your pipeline. And within this box, you can aggregate all the information, all the communication that relates to that specific case. And if you click on this box, you can navigate yourself to an editor where you can see all the communication in a timeline. So whenever there was an email or someone added a comment or uploaded a file or had a chat and took notes, all of these information appears in the middle. And in the right side, you can make some edits on that. So since we are in Gmail, our stack is very related to Google. So we host our application on, or our backend on the Google Cloud. We use MySQL and Datastore as the two databases. Actually, we do an ongoing migration, so Datastore is more used, but I will talk about that later because it causes some problems. Our backend code is mainly Java, but we started to write some Kotlin as well. We do some tasks asynchronously using Spark. We do have a Redis cache for client-side information caching, and we do our deployment by using Docker and Kubernetes. And we use Circle CI as the CI tool. I'm not sure if anyone uses that. It's very similar to Jenkins or whatever, just another tool of that. And for metrics and tracing, we use OpenTrace, and we just push data to Datadog and Lightstep. They are pretty cool products as well. So what I'm going to talk about today, why this query transformation is important, is a thing called saved view. It's really similar to a pipeline. Actually, if you close this editor section, it's essentially a pipeline. Basically, we can say that every pipeline is a special case of saved view where we are grouping the boxes by the stage. But you can customize this. So it's really similar to like a SQL view that you set up and your data is just appearing there. You can do any kind of filtering and then you can define some sorting options and grouping. and some paging as well, pagination. And yeah, up here you can see this, we call them group headers, where you see the name of the group or the thing that you add to that, and the number of the matching boxes in there. And my goal or my task, which I was working on, is that transforming this to a SQL query, because we are migrating our data to MySQL. Yeah. But there are some minds and problems that indicated this change. So there is a term called contention. Anyone is familiar with data store? No, awesome. So contention is a thing which happens. So data store basically it's very similar to some any kind of NoSQL, really similar to DynamoDB. And there is a thing that they represent the data or organize the data into entity groups, and all the data is like stored as a tree. And if the tree or the root gets too many writes at the same time, that we call contention. And since we have lots of boxes and many of our users have huge pipelines, it happens really often. So that was one of the indicator that made us to like switch to another database. And also at the moment, what happens is that if you open Streak, all of your data is loaded into the client, which is obviously causes problem. It has huge memory footprint, like a middle-sized pipeline can eat up like 2 gigabytes for that single tab in your browser, which is pretty bad. And also we have some latency problems. And since our migration is ongoing, we have to maintain like 2 databases at the same time. And also another big problem is that in Google Cloud, you have a fully hosted MySQL solution, but that's 5.6. And that's so that version has like lots of limitations and missing several cool features. We are trying to find a workaround to like upgrade to a better one. But all of these problems basically are related to like scalability and our growth. So we just got more and more customers, and these customers are growing, and they just generate more and more data. And this current stage where we are, it just cannot keep up. So yeah. The 2 APIs that serve this saved view that I showed you before, they are kind of simple. The first one is this pipeline slash the pipeline key slash view slash key slash group. And there's a mode parameter which can switch. So there are 2 APIs, the existing one, and if you pass one, then it goes to my work. And here's the response. It's pretty simple. There is just a name and the box count, and these 2 information is just required to like render the upper labels that you see. And the lower one is to fetch the actual boxes from the database. There is so the first part is really similar. So we navigate to the group and we pass a group key, and then the boxes, and we pass the limit parameter, which specifies the page size. We pass a cursor and the mode also. And that one returns with the previous page cursor, the next page cursor, and the boxes in this page. So that's kind of simple. So what we have right now, or what the initial state was, is that we have this saved view saved as a JSON, and we are passing that all around between the client and the server. And so my idea was to grab this problem as like a model transformation problem and just slice it up. So I could easily like implement something which starts working on this JSON, and then in one giant method, it just ends up with a SQL query, but that's obviously like a wrong solution. So I just sliced it up to 3 main levels. So this first one, the saved view, this is the existing one. This is this JSON representation. And then there is a transformation which produces a DTO structure. I will show that on the next slide, which actually describes this query that we have to pass around. And then there is an internal stage which more technology agnostic, or like more aware of our domain. And then the next stage is just the database. So all of these stages have their very own knowledge about the world, and that's where model transformation comes to play. These are these different layers of understanding about the same thing. So the DTO is strictly business related. It doesn't know about anything else, like what kind of data types we have or anything else. That happens in the internal stage where we fill up all this information with our technology specific information. And then the last stage, this database one, is actually pure like database related. It doesn't know anything about the higher levels. So the conceptual model of a query is pretty simple. Like anyone ever wrote a SQL query has kind of the same imagination. So we have a query where we pass some columns which we want to retrieve, and we do some filtering. The filters can be nested, and then we maybe pass some grouping, and we do some sorting, sometimes some multiple sort, and we obviously want to limit the number of the results. And here's a sample code about it's not all of the details, but the filter and the sort. So here I refer back to the gang of 4 patterns. So the filter DTO is okay. Anyone has an idea what kind of pattern is that? It's not perfectly implemented, but I think it's visible. Yes. No. The class names might help. Yes, it's a composite pattern. Anyone is familiar or? Yes, it's composite pattern is really useful for describing these tree structures where you have like a composite object which can contain other ones, and you have leaf objects which cannot. So that's basically it. And in the sort DTO, there's just a simple like a parent-child relationship with this next pointer. Yeah, so this is about the pattern. The source representation, it was kind of hard to figure out like how to name this slide, because this is all the classes and structures which describe the internal knowledge about the domain. So there is this definition which is filled up with properties. So there is a property which essentially is a column in your pipeline. So it could be the name of the box or the number of emails in the box or anything else. That's a property. And this property has 3 different subtypes. There is a stored property, which means that in MySQL, it's a single column. There is the join property with, no, that's not true. So the stored one is stored in the immediate box table where we store the boxes. The joined one is referring to all the data that we retrieve by joining another table to this table. And there is the custom property, because in the pipeline, you can define your own fields. There are basic data types, and you can just have like custom fields. And those ones are saved as a single JSON column at the moment to MySQL. And therefore, it requires some special way to like read it out. And it was just a good idea to treat it differently. And in this middle part, we have 3 key components. One is the data type, which is responsible to know how to deal with a Boolean or a string or a long in MySQL or in the DTO level, depending on where we are using that. And we have the operators, which are available through the UI and know how to represent this in the database. So the generic idea is to make this database replaceable. But right now, I will just refer to MySQL because that's the only one that we are using, and we don't know if we have to replace. So it knows like how to represent the equals operator or anything else. And then we have the column identifier, which essentially how to grab that column or multiple columns which refer to that data. And I had to come up with this because of 2 reasons. One is this custom property that I referred to before. And the other thing is that in data store, everything or there is a term called key, and the key obviously is the key in data store, but it has two parts. It has the parent key, which can be a string or a number, and it has their own key. So whenever we are saving this to MySQL, we store it in two columns. One is the parent ID, and one is the actual ID of the record that we are referring to. So that's kind of a tricky one to like how to join data in MySQL, which are not in MySQL but in data store. So because of that, we have these three column identifier types. And so some sample code, data type, as you can see, it's really, really simple. These are objects because they don't hold any state. And that's a cool thing about Kotlin, that objects are singleton. And it basically implements two methods. One is the toType. When we retrieve it from the DTO, we know how to process it or how to convert it to the type. And then there is a toSQL method, which we use when we actually render the query later on. And I was talking about the operators, so I show you an operator as well, the nullability operator, which has two actual instances, the is set or is not set. And as you can see, if we are curious about like if something is set, then in MySQL we say if it's not null. And here we use, so here's an example why a sales class is cool when you define these structures, because you can use this when statement and you make sure that you covered all the different cases. So that's the main benefit, or I identified this for the sales class. So it's really not a big deal, and we have tons of classes like that. Pretty much all of these ones have their implementation, but it's really really compact in terms of like the implementation. So yeah, and I was talking about this definition part, like how to describe a property or a column. So here's a screenshot. This is from our source. I hope you can read it. But it's actually a map, and I define a join property which holds the information about the completed task percentage, how many of the tasks related to a box are actually completed. And it's a double, and it's a single expression. So one advantage of these column identifiers that I use is that I can put pretty much anything I want into that. So there's a case code in this column identifier, and it just does some calculation, and that's it. And also, since it's joined, I can define like how to join it to the box table. And once I describe this, I don't have to pass this information to the logic where I do the transformation, because all this data is already defined. So I wouldn't say declarative, but like we have some static data which doesn't change, and then we have the input which can be anything, and the logic which does this transformation is not really interested on anything of it, because it knows only like how to transform this to that. And then when we come to the data part, when we have to actually render this query, then we just use this kind of data. So yeah, architecture, another bad naming for a slide. So the way it works is that when someone calls this API, there is this box getter class. We use these endpoint handlers as like getter or updater. We have this naming convention. And there is one single class which encapsulates everything else. So it's pretty isolated from the existing code base. It's called a saved view SQL service. And what happens first is it fetches the view, that JSON that I was talking about at the very beginning, and it transforms this view to a DTO. It depends on if it's a group retrieving API call or a box fetching API call, because when we are curious about the groups, then we do this grouping logic. But when we fetch the boxes, then for each matching group, this grouping property becomes a filter. Yeah, but that happens in the DTO level. So once we retrieve the DTO out of it, we convert it to this internal representation when we now aware of these properties and the operators and the data types and everything. And once we have that query, we pass it to the JPA transformer. At the very beginning, I just had a native transformer, but we use Hibernate, and it seemed more convenient to have a JPA transformer. So what happens is that first, this JPA transformer renders the full native query, which is actually later on turned out very useful for debugging. And then it pretty much does the same with Hibernate. So I just extract the parameters and put it to a parameter map, and the end is a string which I can pass to Hibernate, and then I just go through this parameter map and just run the query. Yeah, another slide was that just to indicate that this internal or DTO to internal query transformer produces the internal query, and the native one comes up with an SQL query object. I hope you can follow me. So one very interesting problem which I've run into is that how to solve the multiple field sorting problem with pagination. So imagine that we are sorting our boxes based on creation time and then the name of the assigned to person. And the problem is that since we do pagination, we have to encapsulate this information to cursors, right? Which is a string because we are passing it over HTML. So since the sort DTO follows this parent-child relationship, I was able to flatten that object out. So I just convert that structure to a list and then do the same with the internal query sort object, which are essentially the same, but on a different understanding level or model level. And then I'm able to like figure out if the result of the SQL query, which comes back as an array, how many of the columns are or belong to the same property. So if it was a key, then there was 2 columns, and then I know like, yeah, for this property, I read the first 2 columns and the next one belong to the next property. And in general, like, yeah, it's a cross model logic. So it's not a pure like model transformation where all the models are like distinct, but this combination helped me to just get rid of this problem and properly process the cursors. So where we are now, it's not in production yet. What we have right now is a dual writing system where whenever a box is saved, we save it to data store and we save it to MySQL as well. And the next stage before we start moving all the read parts to MySQL is to roll the saved you part to production. I already run the tests for to make sure that that what I wrote actually makes sense and it's correct. There are still a few bugs, but I'm gonna fix it. And we use our own tool. So whenever I have to deal with some bugs or something, we are using our own product to track them, and we have our own sales pipeline and support pipeline and everything, and that's a really cool thing to like identify bugs even before something gets noticed in a more wide audience. And also there might be a case when it turns out that MySQL just doesn't fit, or we have to index too many things and it just doesn't work, and we might want to switch to something more search related like Elasticsearch or something. With this isolated level of transformation, it's pretty simple, because if I want to implement the same transformation for not MySQL, but to Elasticsearch or Postgres or whatever, I only have to modify that part, that very last part of this transformation chain. And also, I'm not 100% sure that these generated queries are performing well enough. So there's gonna be some further query optimization for sure, but that's, I don't know, who knows when it happens. So I really hope that you guys were able to follow me. I tried my best. If you have any questions, then feel free to ask. Yes. Databricks. I'm not sure if I know what Databricks is. I don't think so. It's just naming. It's basically the Google's NoSQL database solution. Yeah. Okay, I think there's no more question. Thank you very much for everything. Thank you.